Nampak tak?
Nampak.
Alright. So chapter 4 for wireless network, ITT640, wireless personal area network or WPAN, so known as WPAN. Okay. So this chapter contain standard for WPAN. After that, principles and IEEE 802.15 standards. Next, we see the Bluetooth, Ultra-Wideband, and wireless sensor network. Okay, so we go to chapter learning outcomes. Upon completion of this chapter, students should be able to describe the standard for WPAN, describe the principle and IEEE 802.15 standards, and explain the Bluetooth UWB and WSN technology. Okay, so you should be able to explain the Bluetooth, Ultra-Wideband, and wireless sensor network technology. Saya punya cursor color merah pula kan. Okay. Dah nampak cursor? Dah tukar? Ada kan?
Ada. Nampak.
Dah biru lah. So we go the first subtopic, standard for wireless personal area network. So we have gambaran lah kat sini kan. Illustrate antara WPAN, LAN, MAN dan juga WAN. Okay, so yang luas sekali antara country to country, state to state, city to city is wide area network kan. Okay, in one city, dalam satu city kalau ada network yang sama, we call as metropolitan area network or MAN. Alright, and in building or campus ataupun satu company kan, maksudnya ada different building pun tapi dia satu location yang sama, so we in local area network. And then yang kita punya kecil ni, yang kita nak masuk ini adalah personal area network, PAN. So contoh kat sini kita ada Bluetooth 802.15.1, Ultra-Wideband 802.15.3, Zigbee 802.50.4. Okay, so semua ada dalam IEEE punya nombor. Okay, standard. Untuk LAN kita pakai 802.11. Kalau wired kita pakai apa? 802.3 ya?
802.3 kot tak silap. Saya pun tak ingat.
Kena ingat lah. Kan? Nanti search balik untuk wired. Okay, WiMAX dalam MAN 802.16. Lebih kurang 15, kita ada 15, 16. Okay, untuk WAN 0.20, 22, 21, 16E, banyak tu. Dan juga termasuk kita punya 4G, 5G kita, cellular. So, wireless personal area networks are used to convey information to over short distances among a private intimate group of participant devices. So, unlike a wireless local area network, WLAN, a connection made through WPAN involve little or no infrastructure or direct connectivity to the world outside the link. Okay, so tak ada infrastructure pun boleh connection. This allow a small power efficient inexpensive solution to be implemented for a wide range of devices. Kan? So WPAN origins in the body LAN project initiated in the early 1990s. Okay, networking personal devices such as a sensor, camera, handheld computer, audio devices, and etc. with a range of around 5 feet. Okay, Around 5 feet, around soldier orang buat dalam satu kelompok soldier kan. Today, networking digital cameras to cell phone, to PDA, to laptop, to printer, and banyak lagi ya. Okay, so most popular application hands-free headset to cell phone. Okay, sini tak ada band kan? Kat wristband kan? Kat tangan tu. Ke Bluetooth kan? Lagi. Contoh. Kamu pernah tengok? IoT kan tak ada ni kan. Okey, IoT lagi. Basikal kita tu apa? Obat kan? Obat kan? Obat.
Obat.
Dan nama-nama lebih kurang macam tu lah kan. Pergi mana dah basikal tu? Nampak pun. Company obat ambil balik ke? Ke dia sedekah kat ni? Keluarga UiTM. Okay, and then kita ada IEEE 2.15 standard ataupun Bluetooth, so use band available globally for unlicensed users. Okay, so tak perlu license lah. Low power, medium rate, lebih kurang 100 second per kilobits per second. So characteristic, okay, short range communication, low power consumption, low cost, small personal network, and communication of devices within a personal space. Okay, so 3 wireless standard are leading the way is the way for WPAN is infrared, IRDA, okay, Bluetooth, and then walaupun Bluetooth 2.50.1 kan, so dia ada lagi macam-macam lagi 2.15. Kita akan tengok the next topic. Each of these standard enables users to connect a variety of devices without having to buy, carry, or connect cables. Yeah. They also provide a way to establish ad hoc networks among the abundance of mobile devices on the market. So, saya masih dalam internet ke? Ke saya terkeluar? Kadang-kadang selalu terkeluar kan? Risau juga.
Masih.
Okay, so kita ada Bluetooth, IRDA, and IEEE 2.15 yang dah mention. Okay, IRDA, Infrared Data Association, communication range up to 1 meter, or to a distance of 2 meters can often be reached. A lower power option for communication up to 20 centimeters. This requires 10 times less power than a full power implementation. Kalau dekat, lagi powerless lah. Bidirectional communication, data transmission from 9,600 bit per second, and then they boleh up to maximum speed of 4 megabit per second. And then Bluetooth, generally discoverable mode, this allow a Bluetooth device to be detected by any other Bluetooth device within its proximity. Kan? Ingat tak dulu-dulu Bluetooth yang mula-mula keluar tu, masa tu kamu umur berapa? Mula-mula keluar Bluetooth yang kalau nak connect kena pakai pin. Masa tak ada handphone lagi.
Saya kena Bluetooth masa saya form 1 je.
Masa tu ada pin tak? Nak connect pakai pin tak?
Ada pakai pin.
Itu awal-awal lah tu. Kan? Sekarang tak perlu pin lah. Okay, general discovered mode, this allow a Bluetooth device to be detected by any other Bluetooth device within its proximity. Limited discoverable mode, okay, ada juga limited discoverable mode, only where defined device will be able to detect device in this mode. This mode will be used when a user has many Bluetooth devices and wants them to discover each other automatically. So kita nak bagi nampak, tak nampak kan? Non-discoverable mode, this make the device invisible to other devices so it cannot be detected. Macam SSID lah, kadang-kadang kamu boleh hide kan. Alright, so 802.15, okay, IEEE kita ada 4 task group. Task group 1, WPAN or Bluetooth created the WPAN. 802.1 15.1, okay, standard based on the Bluetooth version 1.1 specification. And then kita ada task group tu, coexistence mechanism. Okay, developing the recommended practice to facilitate the coexistence of WPAN 802.15 and WLAN 802.11 technologies. Okay, 802.15 WPAN task group 3. Task group 3 high rate WPAN. Okay, so publish a new standard for high rate lebih kurang 20 megabit per second or higher for WPAN. Okay, 802.50 WPAN task group 4. Okay, task group 4 yang last is for low rate long battery life, establish a low rate, okay, lebih kurang 200 kilobit per second maximum. So solution with long battery life, so lebih kepada long battery life lah. So many months to many years and low complexity. So this is a comparison dia. Bluetooth dia tunjuk sampai version 2 je kan. So kita ada sampai version 5 kan. So ada yang dah boleh pergi sampai 20-30 megabit per second. Boleh. IDA kan. IDA boleh pergi, boleh laju lagi kan. Tapi kena dekat lah kan. Lagi dekat lagi laju lah. So frekuensi use yang ni pakai wavelength, yang ni pakai frekuensi. Belajar kan wavelength, apa beza wavelength dengan frekuensi? Ingat tak? Tak ingat? Frekuensi ada gemuk tinggi kan? Wavelength? Kena buka balik. Kena buka balik chapter 2 kan? Wavelength. Betul? Saya yang buat slide tu kan?
Betul.
Kamu yang tak ingat. Alright. Required lines of sight for communication RDA. Bluetooth automatic device discovery communicates through physical barrier and use Bluetooth. Dia macam redundant tak? Kan? Use Bluetooth as the foundation coexistence with 802.11 devices. Okay, so we go to next subtopic 802.15 standard. Okay, principle and standard. So 802.15 is a specification driven by the Institute of Electrical and Electronic Engineers, or IEEE, to develop consensus standard for short-range wireless network or wireless personal area network. So it has similar goals to Bluetooth in that it looks to address wireless networking of portable and mobile computing devices such as PC, PDA, smartphone, peripheral, consumer electronic, embedded devices, lain-lain. Right? So 802.15 WPAN working group was established in 1999 as part of the Local and Metropolitan Area Network Standards Committee of the IEEE. So the first one kita tengok 802.50.1 is Bluetooth. More commonly known as a Bluetooth, is a low data rate, low power wireless networking standard aimed at replacing cable between lightweight devices. So this design permit the Bluetooth Special Interest Group or SIG. Special Interest Group is SIG. So ada banyak SIG. Bila kita ada SIG, kita tengoklah siapa yang minat boleh masuk kan. Okay. Boleh masuk dan buat research on the specific bidang yang kita buat SIG tu. Okay, this SIG to compose this component into application specific profile. So 802.50.2 for task group 2 coexistence mechanism yang tadi. So this developing the recommended practice to facilitate the coexistence of WPAN and WLAN. Okay, dia nak coexistence antara dua ni. Part of this task involve developing a coexistence model to quantify the mutual interference of a WPAN and WLAN. Once approved, this outcome of task group 2 will become IEEE 802.50.2 specification. Okay, task group 3, high rate WPAN. So it's started to publish a new standard for high rate 20 megabit per second or higher in WPAN. Okay, WPAN in addition to high data rate, 802.50.3 also has to provide a means for low power and low cost solution to address the needs of portable consumer electronic, digital imaging and multimedia application. And then task group 4 is charted to establish a low data rate solution with long battery life. So dia lebih kepada power consumption. Dia boleh ingat, dia boleh apa? Dia more on, kalau boleh tu tak mau makan bateri banyak kan. And low complexity satu lagi. It is intended to operate in the unlicensed international frequency band and is targeted at sensor, interactive toys, smart batch, home automation and remote control. It is a basis of ZigBee, ISA 100.11a, wireless HART, MyWi pula dah kan, macam kan kereta kita 6 low WPAN, track or snap specification, each of which further extend the standard by developing the upper layer which are not defined in 802.50.4. So in particular, 6 low PAN define a binding for the IPv6 version of the internet protocol IP over WPAN. So 6 ni IPv6, low WPAN kan, LO WPAN, okay. And it is self-used by upper layer like track. So 802.50.4 provides for very low cost communication of nearby devices with little to no underlying infrastructure. The concept of IEEE 802.50.4 is to provide communication over distances up to about 10 meters and with maximum transfer data rate of 250 kilobit per second. And then kita ada 802.50.5. It is for mesh networking. So it provides the architectural framework, promotes interoperable, stable and scalable wireless mesh networking. Kan banyak router, mesh router kan. So this composed of two parts, low rate WPAN mesh and high rate WPAN mesh network. So common features of both mesh include network initialization, addressing and multi-hop unicasting. Okay, and then 50.6, 2.50.6 body area network. So ni adalah task group 6. Dah ada sampai task group 6. So semua sampai 10 kan. Yang tadi kita tunjuk ada 4 saja. Okay, tu slide daripada ITT640. Masa tu ada 4, sekarang kita dah ada 6, 7, 10 dah ada kan. Okay, task group 6 was formed in November 2007, focus on a low power and short range wireless standard to be optimized for devices and operation or in around a human body. Luar ke dalam body manusia? Luar ke? Bukan letak chip dalam badan? Macam vaksin? Bukan lah. So to serve a variety of applications including medical, consumer electronic and personal entertainment. 802.50.7 kita ada visible light communication. So task group 7 ni visible light communication task group has complete draft 5C of a PHY and MAC standard for visible light communication. So the meeting for task group 7 was held during January 2009 where it was charted to write standard for free space optical communication using visible light. So apa salahnya kita pakai laser tapi kita pakai kat tempat tinggi-tinggi kan, boleh buat wifi kan. Ada wireless network guna pancaran laser macam RDA, tapi RDA kan short range kan, ni ke long range sikit. And then task group 8, peer-aware communication, to develop a standard for peer-aware communication that optimized for peer-to-peer and infrastructure-less communication with fully distributed coordination operating in bands below 11 GHz. The proposed standard has their targeted data rate, so features of the proposed include discovery for peer information without association, discovery of the number of devices in the network, good connection with simultaneous membership in multiple groups, typically up to 10, relative positioning, multi-hop, relay, and security. So, task group 8. Task group 9, 802.50.9 for key management protocol. So, approval on 7 December 2011 for our task group to develop a recommended practice for the transfer of key management protocol, KMP datagram. So, define a message framework based on information element as a transport method for key management protocol datagram and guidelines for the use of some existing KMP with IEEE standard 802.50.4. The recommended practice will not create a new KMP. So the adding KMP support is critical to a proper security framework. Some of the existing KMPs that it may address IETF, ANA, HIP, IKE version 2, IEEE standard 802. Something point belas kan, and 4-way handshake. Kita dengar sebelum ni 3-way handshake kan, sekarang dah ada 4-way handshake. So based on protocol. Last kita ada layer 2 routing for task group 10. 802.50.10 receive IEEE standard board approval on 23rd August 2013 to form a task group to develop a recommended practice for routing packet in dynamically changed 802.50.4 wireless network with minimal impact to route handling. This goal is to extend the coverage area as the number of nodes increase. The route related capability that the recommended practice will be provide include the following. So kita boleh ada route establishment, dynamic route reconfiguration, discovery and addition of new nodes, breaking and establish route, loss and recurrence of route, real-time gathering of link status allowing for single hop appearance at the networking layer, support for broadcast, support for multicast, effective frame forwarding. Dah macam dengan router kan, router wired kan, kita nak buat macam tu. Untuk WPAN maksudnya nanti kan ada IP lah kan, betul? Dia ada routing, tapi kita tak takut sebab kita ada IPv6 kan, yang memang muat untuk kebanyakan device seluruh dunia. Semua boleh jadi public, jangan risau. So habis 2 subtopik, kita ada lagi 3 Bluetooth, Ultra-Wideband and then wireless sensor network. So Bluetooth, much of the WPAN focus today is around Bluetooth. Started with Ericsson's Bluetooth project in 1994. Ni after Danish King Harald Blatten, kan? Blatten, apa berkaitan dengan Bluetooth? Dia ada gigi biru ke? King ni. Pada tahun 940, 940 and 981, dia mati 981. Who was found blueberries. Dia found blueberries, bukan found. So macam mana dia boleh jumpa blueberries kan? Radio frequency communication between cell phone over short distances. Okay. So dia jumpa 1994, tapi King Harald Blatten ni dia ambil sebenarnya orang ni pada tahun 1940 kan. Lama lah. Dia admire kot kan. And then ada kaitan dengan blueberries. And then gigi, lepas makan blueberry, gigi dia berbiru. Macam tu kot. Kan? Radio frequency communication between cell phone over short distances. Siapa lagi yang SIG dengan Bluetooth? Intel, IBM, Nokia, Toshiba, Ericsson form Bluetooth SIG in May 1998. Version 1, okay, Bluetooth version 1 was beginning came out later 1999. So 802.50.1 approved in 2002. Selepas tu baru approved as 802.50.1. Okay, it's based on Bluetooth So key features: lower power, 10 microampere in standby, 50 milliampere while transmitting. So cheap, around $5 per device, and small 9mm single chips. So this is frequency dia lebih kurang 2.4 kan, dia antara 2.4.2.402 sampai 2.48. Yang sini atas ni dikira dalam gigahertz ha. Yang tulis kat sini dalam megahertz. So maksudnya 2.402 gigahertz. Sama dengan 2402 megahertz. Ha, yang tu. 2.402 kat sini kecil je. And then sampai 2.48 sini ya. So lebih kurang dalam 23 MHz in some country. Dia based on country lah yang sparekan radio ni kan. Data rate is about 1 megabit per second. Version 1.2, 720 kilobit per second. User boleh dapat 3 megabit per second in version 3. Okay. So channel bandwidth 1 MHz. So range up to 10 meter can be extended further. RF hopping, radio frequency hopping 1600 times per second. Okay. Ataupun 625 microsecond per hop. Okay. Security challenge response authentication is guna 128-bit encryption key. So and then output power kita ada class 1, class 2, class 3. Okay. So 20 decibel meter lah. dBm apa? Maximum to 0.1 watt dalam 100 meter. Class 3 10 meter kan. 10 meter macam tak keluar power dia kan. 0 dBm. So, kalau biasa-biasa tak jauh tak dekat kelas 2 lah. 4 dBm dalam 2.5 megawatt. Mega ke milliwatt? Sorry, milliwatt. Mega besar. So Bluetooth connection can connect up to 8 devices simultaneously. Use transmission technique called spread spectrum frequency hopping. So FHSS, randomly chosen frequency within a designated range, changing from one to another on a regular basis. The transmitter change frequency 1,600 times every second, meaning that more devices can make full use of limited slice of the radio spectrum. Since every Bluetooth transmitter use spread spectrum transmitted automatically, it is unlikely that two transmitters will be on the same frequency at the same time. Yang ni banyak juga saya ambil daripada slide kawan kamu kan. So when Bluetooth capable devices come within range of one another, an electronic conversation take place to determine whether they have data to share to whether one needs to control the other. So the user doesn't have to press button or give a command. The electric conversation happen automatically. Once the conversation has occurred, the devices, whether they're part of a computer system or stereo, form a network. So dia akan form a network lah. Yang kita belajar ada apa tu? Piconet, Piconet, Scatternet kan. Okay, Bluetooth system create a personal network or Piconet that may fill a room or may encompass no more distance than that between the cell phone on a belt clip on and the headset of your head. So once Piconet established, Piconet dengan Piconet kalau establish jadi apa? Scatternet kan. So the member randomly hop frequency in unison, so they stay in touch with one another and avoid other Piconet that may be operating in the same room. Okay, so Piconet dengan Scatternet ni adalah two network topologies. So Piconet ni nampak dia bagi dua kan. Kalau ada tiga lah, maksudnya dia tak connect pun antara network. Dia cuma antara device dengan main device saja. Okay, so dipanggil Piconet. So daripada main device dengan main device yang lain, kita dah panggil scatternet. Ini operation dia banyak ah. Okay, ni scatternet. So a scatternet is formed when two or more Piconet are linked by a common Bluetooth-enabled device. A device is present in multiple Piconet is synchronized to the master ataupun primary device of each Piconet with which it is currently communicating and set the hopping pattern of the Piconet. Okay, so saya letak ni banyak contoh-contoh kan, use case, user case, dan contoh dekat Iran kan. Okay, Iran share video pakai scatternet je, pakai Bluetooth je kan. So kita ada Bluetooth 2.1, so kamu baca ni 3, 4 kan, Bluetooth low energy and yang latest, right? So saya tak baca dah ni, banyak lah. So saya nak pergi ke next Ultra-Wideband. Belum lagi. Okay, so ni dia punya parameters. Ada lagi transport layer, link layer dia pakai apa. Technical sikit lah. Bluetooth middle layer. Security. Security dia ada juga security ya. Ada encrypt, decrypt kan. So, maksudnya tengah-tengah kita kalau kita cuba sniff pun nampak encryption lah. Nampak encrypted text lah kan. Kena decrypt dulu baru boleh baca. So application ada banyak lah Bluetooth kan. Kan untuk apa nama, macam tadi saya sebut apa benda-benda yang tak tulis ni kan. Nama apa tu? Obat kan. Dekat tangan tu, wristband. Ramai orang pakai sekarang kan. Mi band apa semua tu kan. Okay, so next topic is ultra wideband ataupun known as UWB. So based on transmission of very short pulse with relative low energy. So may see increase use in the field of wireless communication in the near future. Because of the huge bandwidth, UWB will have a good material penetration capability. UWB radio signal occupies a bandwidth of more than 500 MHz or fractional bandwidth of larger than 0.20. So according to channel capacity formula, this large bandwidth provide a very high capacity. This high processing gain can be achieved that allow the access of a large number of users to the system. So the impulse radio usually is a carrier-less. Okay, for example, baseband radio technique, and accordingly in the radio technique, no mixer is needed. Therefore, the implementation of such a system is simple, which means that low-cost transmitter receiver can be achieved when compared to the conventional radio frequency ataupun RF carrier system. So bila start ni, through year 1960 dah ada. Until 1990s, the United States military developed a UWB technology that was first used in ground penetrating radar. Dia guna kat situ mula-mula. In 1998, the Federal Communication Commission, FCC kamu tahu tak apa? Kalau siapa suka beli kad untuk komputer, desktop lah, so dia akan tengok tiap-tiap item tu dia ada FCC number. Kan? So the FCC recognized the significance of UWB technology and initiated the regulatory review process of the technology in 1998. Consequently, in February 2002, the FCC report appeared in which UWB technology was authorized for the commercial use with different application operating frequency bands as well as the transmitted power spectral density because UWB system operate in a very large bandwidth. Tu beza dia kan. They need to share the spectrum with other users as well as with the existing communication system and Consequently, interference may occur. Besides from the interference from other users, the UWB propagation channel will cause disturbances. Okay. So summary dia, kita ada wireless technology to quickly transmit very large amount of digital data over a extremely wide frequency spectrum at very low power and very short distances. UWB signal are typically produced by applying an impulse monocycle or step signal to resonant antenna. Result is that is use a wide spectrum of bandwidth in frequency domain. So very low power dia, 41 dBm per megahertz. Ni consider yang DCC punya bacaan lah. And then very wide bandwidth. Bandwidth pun tadi berapa je kan? Yang ni boleh pergi sampai 10.6 GHz dia punya bandwidth dia. Untuk ni. Bluetooth tadi berapa? Sikit je kan? 2.4 dengan 2.4. Maksudnya 0.1 lah GHz kan. Tak besar kan. So why is UWB so interesting? Because besar tadi kan. Ada 10 GHz kan boleh pakai bandwidth dia. So 7.5 GHz of free spectrum in US. Ada free spectrum. FCC recently legalized UWB for commercial use. Boleh pakai banyak spectrum allocation overlays existing user, but it's allowed of power level is very low to minimize interference. So very high data rates. Kan dalam 10 kaki boleh dapat 500 megabit per second. So can be achieved at distance of 10 feet under current regulation. So simple CMOS transmitter at very low power. Dah power consumption dah fikir dah dalam UWB kan. Low power is CMOS friendly. Boleh pakai bateri CMOS je kan. Bateri bulat kecil tu kan. So suitable for battery operated devices. Nampak. More low radio data rate scale with the shorter path, which made possible with ever faster CMOS circuit. So low cost, nearly all digital radio. Integration of more component on a chip ataupun tak ada antenna. Okay, so kamu boleh study further dalam basic signaling untuk UWB. And then FCC tadi kan. Ada lagi ni technical sikit. And then spectrum. Apa teknologi dia. Next. Saya sikit. The impulse radio ni apa? Okay, impulse radio. Dia ada impulse radio UWB. Pulse of very short duration. Okay, they typically in the order of sub-nanosecond are transmitted. Laju. Okay, so ada scheme of impulse radio, ada bi-phase modulation, pulse amplitude modulation, pump, pulse position modulation. Ni lagi teknikal kan? Kalau kata kamu tulis paper ke apa, masukkan sekali dia punya equation ni. Ni orang engineering sukalah, saya tak pandai kan. Okay. Dia ada multiband autonomous frequency division multiplexing. Belajar multiplexing pula kan. Ni multiplexing dalam UWB lah. So advantages of UWB, ability to work with low SNR, signal, noise, R apa? Rate, signal noise rate lah.
Rate.
So the Shannon formula indicate that the channel capacity is low, only logarithmically dependent on SNR. So low probability of intercept or detection. Okay, because of the low average transmission power, UWB system have an inherent ability to detection and interception, resistant to jamming. No jammer can jam every frequency in the UWB spectrum at once. So So kalau kata dalam Cisco ke dalam datacom tu kena kira SNR dia buat apa. Luckily tak ada soalan dia dalam ITT640. Ini contoh-contoh kita pakai yang paling dulu pakai untuk radar kan. Radar, wireless sensor, and then untuk hospital ada medical imaging. And then untuk dalam kereta kita boleh pakai positional location and then RFID. Betul tak? So semua tu kalau sebut RFID kita tahu oh dia under UWB. Right. So dia ada antena. Okay, antena 1, antena 2, antena 3, antena 4, antena 5, antena 6. Ini antena. Ini contoh guna radar, UWB radar, dan UWB intrusion detection. Okay, so sampai ke bab yang akhir, wireless, bab akhir lah, sub topik yang tadi is wireless sensor network WSN. So sensor network division, sensor network is a collection of collaborating sensors nodes, ad hoc tiny nodes with sensor capability forming a temporary network without the aid of central administration or support services. Sensor nodes can collect, process, analyze and disseminate data in order to provide access to information anytime and anywhere. So WSM lah, dia ada consist of base station and number wireless sensor ataupun we call as node lah. Ni ada banyak node. Okay, ni raja wireless sensor network component, ada location finding system, mobilizer, sensor ADC, ada sensing unit sebelum pergi ke processing unit, and then dia ada transceiver lah. So ni power lah, guna power. So sensor network features large number of sensor, low energy use, efficient use of the small memory, data aggregation, network self organization, collaborative signal processing and querying ability. So in history development start 1998 when many engineers realized that Wi-Fi and Bluetooth were going to be unsuitable for many applications. Dah ada orang tahu, dah ada Wi-Fi dengan Bluetooth pun belum tentu kan. So they develop this wireless sensor network. So 802.50.4 standard was complete in May 2003. Ni contoh kita boleh pakai ZigBee ya untuk wireless sensor network. Okay, and kita ada low rate WPAN ZigBee, so it's simpler and less expensive than Bluetooth. Majority to ease of installation, reliable data transfer, short range operation, extremely low cost, reasonable battery life, can maintain a simple and flexible protocol. Raw data rate will be high enough, maximum of 250 kilobit per second, to satisfy a set of simple needs such as interactive toys, but it also scalable down to the needs of sensor and automation needs. So about around 20 kilobit per second or below. So using wireless communication. Boleh. So ni contoh dia kita pakai untuk WSN kita pakai ZigBee. Pernah dengar ZigBee? Student mana you projek banyak buat benda ni. Sebelum ni lah kan dia pakai ZigBee.
Nah, pernah dengar.
Sekarang pakai dengan Pi kan. Raspberry Pi. Dia tak mau pakai Wi-Fi, dia pakai ZigBee. Macam tu lah. Dalam Raspberry Pi kadang-kadang dah ada Wi-Fi. So nak pakai ZigBee. So ZigBee is a working group much the same as the Wi-Fi Alliance or the WiMAX Forum. Geng-geng yang buat WiMAX tadi, dia orang terfikir nak buat this ZigBee. Okay. So dia orang lah yang tak mau rely on Bluetooth dengan Wi-Fi kan. Mungkin dia boleh kita cut satu lagi. Sebenarnya dia buat WiMAX kan. Sebab satu lagi is this ZigBee can used in sensory kan. Technological standards created for control and sensor network. So based on IEEE 2.15.4 standard created the ZigBee by the ZigBee Alliance. Geng itu dipanggil ZigBee Alliance. Okay, so dia pilih nama ni because dia rasa nama ni erotik kan, ingatkan erotik kan? Erotik je. A zigzagging pattern of V between flowers. Okay, symbolize communication between nodes in the mesh network. Nama orang bagi nama kan. Macam semalam ITT640 kita orang dah sampai ke GNU. Ingat lagi GNU?
Ingat.
GNU. GNU stand for what? GNU not Unix maksud dia. GNU not Unix. GNU is GNU not Unix. Kan? Sebab dia nak buat Linux kan. Linux kan bukan Unix kan. Dia nak beritahu Linux ni bukan Unix kan. Sebab tu sekarang kita panggil Unix Lite kan untuk Linux dan seangkatan dia. So ZigBee standard for mesh networking on IEEE 2.15.4 standard 2 kali ulang. Reliability through mesh connectivity designed for low power application, very long battery life, low data rate, okay, 250 kilobit per second depending on band. Then very secure. Tak sangka pula dia boleh very secure. Guna AES 128 encryption available. Besar kan. Self-configuring, allow and ad hoc networks, ease of installation and configuration. Ni dia comparekan ZigBee dengan Wi-Fi dengan Bluetooth. Okay, so speed menang lagi kat orang lain lah. ZigBee dia tak fikir sangat pasal speed. Dia fikir pasal data rate kan. Okay, and then power consumption, protocol and stack and stronghold. Ini contoh guna home automation kan. So ni contoh first there was a extend. Macam ada dekat smart home kan, smart. Okay, contoh extend lah. Kamu cari lah ni contoh-contoh dia punya ni. Dia start dengan kita nak clap on, clap off. Tepuk tangan, buka. Kamu tengok cerita ni. Saya pernah suruh kamu tengok IMDb. Sekarang kamu tak nampak lah. Sorry, jap. Tak share ni. Nampak kan?
Nampak saya.
Accepted 2006. Ni. Dia ada clap in, clap out. Mana tengok cerita ni? Best ni?
Ui, lamanya cerita ni tu. Saya tak pernah tengok.
Best ni, tengok lah, seronok. Yang Die Hard dia kan? Die Hard 4. Justin Long. Apa dalam Die Hard panggil? Farrell. Tak ingat nama. Alright. So, itu saja kot. Yang home automation. Yang lain. Boleh tengok dia punya technical of ZigBee lah. Lecture dia. Frequency band and data rates. Okay. Tadi dekat layer bawah, sekarang layer ni pula. Okay, message propagation dia macam mana? Kan, pakai topologi apa? Okay, so kamu boleh go deep lah. Banyak ni saya copy daripada slide 575. Okay. Ni ada saya rasa. Daripada slide lama ada ni. Tak ada. Tak keluar, tak ada. Kena buka yang ada. apa nama, slide 575. Contoh ZigBee coordinator kan. Ni SB kan. Okay. Dia ada ZigBee router, ZigBee coordinator, and then end device. Dia punya structure MAC lagi. Traffic type dia, data is sporadic, application defined rate, data is intermittent. Ada data is intermittent . So application external stimulus defined rate, optimum power saving, for example light switch. Data is repetitive, device get guaranteed time slot, for example mouse. Ni bukan types of ni kan, dia jenis-jenis data, type of traffic. Okay, so data transfer antara coordinator device to coordinator. And then kita ada beacons, okay, super frame. So beacons are used for starting super frame and synchronizing the associated devices, announcing the existence of PAN, informing pending data in coordinators. So ZigBee routing guna AODV tadi dah ada, kalau tengok tadi. Discovery. So ZigBee stack network layer support a route discovery. Okay, especially in which a mesh network can be requested to find the best available route to the destination when sending a message. So route discovery is initiated when requested by a data transmission request. Ada option dia lagi. Mechanism, discovery mechanism. Ni table dia. Cepat-cepat ni. Target market untuk ZigBee, building automation, healthcare, industrial control, smart home, PC environment, consumer electronic, smart home lah kan. Okay. Sebelah home, tempat kerja. Ni antara usage of sensor network. Environmental observation. Ni ramai student kita sini-sini kamu buat. Water, air pollution detection, forest fire detection, animal habitat monitoring. So benda ni ramai orang dah buat ni, tapi tak tahulah implementation dia setakat mana. Dah banyak research, dah banyak produk-produk keluar, tinggal masa nak majukan, nak commercialize, nak tolong beli je kan. Tolong implement je. Monitoring, battlefield surveillance, vehicle traffic monitoring, tracking the position of the enemy. Nak tracking pakai sensor kan. Building monitoring climate change evolution. Macam mana nak track enemy ni kat atas? Siapa tahu? Macam mana nak track position of enemy? No idea.
Pakai sensor.
Okay, katakanlah kita nak perang dengan satu negara kan. Negara mana lah? Negara yang tak wujud contoh. Kita nak perang dengan Wakanda lah.
boleh sir.
Okay, so kita supply baju perang kat Wakanda tu, kita letaklah ZigBee je siap. Nanti kita boleh detect kan. Macam tu.
Dia pakai satellite kot.
Itu senang sangat kan. Maksudnya musuh pun pakai barang yang kita beli kan. Sekarang ni Malaysia macam tu tak?
Pasti.
Kita nak perang dengan Rusia. Kita beli jet Rusia kan. Sukhoi.
Betul.
Dia boleh detect kan. Takkan dia tak siap kan. Dia tak cerita kan. Boleh tracking position. Maksudnya kita kena jadi negara pengeluar lah kan. Ataupun kita buat sendiri, kita pakai sendiri kan. Kita tak mau jual pun, jangan pakai yang orang lain punya. Susah tak? Contoh negara yang sendiri siapa? Jerman kan, Jerman memang kan. Dia orang daripada awal bagi perang kan. Banyak produk-produk dah. Okay, daripada military kepada building monitoring, healthcare pun banyak kan. Being implanted in human body. Contoh dia apa? Vaksin lah. Boleh ke?
Vaksin.
Vaksin ataupun kita nak buat reality game ke, macam Hunger Game ke, kita implant kan. Benda tu kan chip kat ni kan, boleh pecah kepala ke apa kan. Ada C4 pula sekali kan. Mana nak masuk benda tu? Bateri pakai bateri apa? Nak cucukkan bateri pun susah kan. Ke dia nak buat sensor macam chip saja kan. RFID apa semua yang tak payah pakai bateri. RFID pakai bateri. Tashengo kamu punya kad. Tashengo tu ada kad. Tashengo tu ada bateri tak?
Tak
Tak
ada.
ada kan. Dia boleh detect kan. Apa yang dia boleh detect? Infrared lah. Ataupun X-ray kan. Teknologi X-ray boleh scan. Ni contoh lain ada sensor node Mika tu. Cari boleh further research. Okay, this part. Alright. That's all for chapter 4. Habis juga kan, walaupun saya skip. Yang technical part. Kena baca banyak kali tu kan, nak faham.